Huge nerd. I really like Magic the Gathering, so I decided instead of building a to-do list API that generally is kind of how you see all these different tutorials go, I was like, you know what, I'm going to start working on a little project that I've been wanting to for a long time and kind of kill two birds with one stone here. So we're going to be building just a very, very, very simple, basic API that kind of lays the groundwork for starting to manage cards in a database for Magic the Gathering. But first of all, before we get into all the code, I just kind of want to talk about just some very basic general knowledge of .NET Core. So what is .NET Core? Well, it's a cross-platform framework for building modern cloud-based web applications on Windows, Mac, or Linux. So the key part there is that it's cross-platform. So if you were working with just the .NET framework, what we had was you would have to get individual builds for each one of those platforms that you were wanting to target. And so now with .NET Core, Microsoft has essentially done away with that, and you can just run one framework, and it should work on all the platforms. The big plus is that it's completely open source by Microsoft. You can find it on their GitHub. All the code that they use in .NET Core and ASP.NET Core is completely open sourced, and they're always looking for contributors if that's something that floats your boat. The other big thing is that it's the future of .NET. So back in May, after the Build conference with Microsoft, they announced that starting with .NET 5, .NET Core is going to be coming back under the umbrella of .NET Framework. And it basically will shape the .NET Framework going forward. So essentially, it was their way of saying .NET Core is the future. If you don't know it and you want to keep using .NET Core or .NET Framework, this is the way it's going, so you should probably start learning .NET Core. So differences between .NET Core and .NET Framework. Really, .NET Core is just a modular subset version of the full .NET Framework. It's essentially, they basically modularized, if I can talk today, .NET Framework, and essentially over time, like from version 1 now to version 3, which is coming out soon, they've just been adding more and more features, so it's more fully featured to do all the things that .NET Framework could do. Like I said, it's portable across all the platforms, and like I said earlier, with .NET 5, Core is coming back to the .NET Framework umbrella. So you'll want to download the .NET Core SDK. You can find that at .net.microsoft.com/download. We'll be using the version 2.2 during this talk. Version 3.0 is out, but it's only available as a preview. It's coming out fully, I believe, sometime this fall. I think September, might be October. Let's see. But everything we talk about today should totally be compatible with 3.0. So once you download the .NET Core SDK, you'll get a CLI tool, so a command line interface tool, and you can use this to verify that .NET has been installed correctly by just running .NET -- version. The really nice thing that I really like about .NET Core is that you can run multiple versions in tandem. So you don't have to, like, they all are essentially stored in the same place on your hard drive, and you can just run .NET -- list -- SDKs, and it'll show you all the versions that you have installed. And then you essentially just dictate which version you want to use for whatever project you're creating. So it's nice, like on my machine, I've been trying out some of the 3.0 stuff, so I have that version, and I have like 5 versions of 2.2 as they've been coming out installed as well. So just to quickly kind of run over some of the useful commands that we'll be using. So first and foremost, we're going to be creating a .NET Core project. To do this, you simply just have to run .NET new. And so .NET new, if you do -H, That's -H is it's a helper flag, and it'll give you any helper text for the command you're trying to do. So if you just did .NET-H, that's really hard to say. If you just run that with just no new there, it will give you just general helper text on .NET. If you run it with new, it'll give you general helper text on like actually running the new command. And so if you run that with the helper flag, it'll actually give you a list of all the different project templates that are available. And it actually looks like this. So just actually kind of show, that's really small, isn't it? Is that really small? Can I, wow, that's super small. There we go, okay. .NET, new. Okay, so we have a lot of different types of projects that we can create. Some of these are, when you first get started, you won't see necessarily all of these. Like for me, I think, actually no, I've set it up to where you should see all the same things. If you've installed .NET 3, you'll see some of the new preview templates that they have available. So what we're building today is a web API, so we actually want to create a web API project. So we would just run .NET new web API -n for name, and then the project name that you want to give it. Some other useful commands while you're working with the project are .NET run, that just simply runs your project. .NET watch run, that will run your project, but it also watches for any changes. So if you make any changes, you can then refresh or like rerun your like your request in Postman or whatever you're using, and it'll get those changes. And then .NET publish allows you to actually publish your project, which really just in a sense just creates a build that you can use for deployment. It creates things like the DLLs and things that you'll need. Okay, so let's get into the code. We have a few more slides when we get into deployment, but first of all, I just kind of want to run through the actual code for the API. So when you actually create a new project, and it's a new web API project, it's actually going to really just set up your project for you. It gives you a very simple values controller. So like this is super basic. It's not connecting to any sort of database. It's not connecting to any sort of other external APIs or anything like that. It doesn't even have any models or anything like that set up. It's just a very basic, like, here's something just to kind of show you what's going on. So as we can see here, you have just a simple get to get all the values. It just returns a list of strings. And then you have like a get where you can pass an ID, and whatever ID you give it, it's just going to return a value string. Post wasn't even implemented. And then you have put and delete. So it's a very basic, just kind of skeleton project for you to get things started. And then of course it has like your program. This is like where your API project starts. It runs everything in the startup. And this is just basically setting up configuration for your project itself. So because I'm very bad at coding live in front of people, I went ahead and did a lot of this development beforehand, and we will just be stepping through the code. It's very simple, very basic, but it should kind of get the point across as to what I'm trying to show you here. So what I did is, first of all, I got rid of the values controller. We don't need that. It was just kind of there to show what we're doing. And so we created an actual cards controller. So like I said at the beginning, we're creating an API that will allow us to manage cards in a database, and cards are Magic the Gathering cards. And so what we have here is we have a very simple get that essentially goes into our context for our database. So essentially what we're using here is Entity Framework Core. And so entity framework is just an ORM that is essentially setting on top of your database and allows you to communicate with it. And so for the purposes of this demo, we're just using a in-memory database. We don't have an actual database set up anywhere. It's just all within memory. So anytime you restart the application, you go back to a zero state. And so what we have here is we just have a constructor that is taking in our card context. To kind of dive into that a little bit, the card context is it derives from DB context. This is an entity framework construct. And so essentially what we do here is we create any sets that we want to have for our cards. So obviously we just need one for the purposes of this. And we just say like, okay, it has a DB set of cards. And then we can, whenever these card models are created, we can also do some cool stuff like, I didn't want to have like each card have an ID because there's data with each card that can be put together to basically give it a unique ID. So essentially I use this hasKey method to run this expression so that whenever you're creating a card, you take this, the set code that it'll have and a collection number, you put those together, and that is your unique key that you'll use for this entity. So back to the controller. So that's just a little bit like Entity Framework Core is like a whole hour talk in and on its own. So that's just a very high level basic concept of that. So essentially we've created our context and we've essentially injected it into our controller so that we can have access to it. The context is what allows us to add, remove, update, things like that, to the actual database itself. And so for just the regular get, this is if we went to our API endpoint for our cards and we just said, I'm just sending you a simple GET request, it's going to run this action. This is an attribute here that tells this, lets .NET know that, hey, this is a GET request. So we expect this to be handled through whenever someone is actually sending us a GET request. And so we're also saying, hey, it returns an action result, and it's within that action result, we expect there to be some sort of enumerable, like a list or anything like that that derives from IEnumerable. We expect basically a list of cards to come back. So essentially, we just wrap our context and say, hey, just get me the cards back from this context that you have stored, and just wrap it in an OK so that it comes back as like a 200 OK response. And then to actually get individual cards, we do something very similar. We have, again, an HTTP GET, but this time we have an actual parameter. We're going to pass it an ID, and then it's going to use that ID to find the card from the context. So it goes through and it says, this is actually a link statement. So this is just using just kind of standard link methods to find the card that matches the ID. And so we do single or default here because you could be requesting a card that doesn't exist. And so if you didn't do default, it would throw an error. If you do default, it handles it a lot more gracefully and just basically sets the card to null, basically saying, hey, I didn't find anything. So we run this expression for the single or default, and we basically say, hey, the ID that I gave you, compare it to essentially each card that we have in our database and see if any of them actually match up. And so if we find one, great, return it. If we don't, just return a not found. So what's nice about this is that these are just helper methods, helper actions that are built into .NET that allow you to say, hey, I don't want to have to tell you like how to do a not found. You should already know how to do that. So I'm just going to return this not found, and it'll actually say, okay, I know to return a 404 and like a message that says, hey, this wasn't found. And so it's a lot better than like trying to create the action yourself. And then, let's see. The last one that I actually had implemented was HTTP posts. So this is just a simple post request. We can put this on this argument. This is another attribute. This is essentially just telling .NET, hey, for a post request, you're going to need a card, but expect to get it from the body of the request. And so we then get the ID from the card that we passed in, and then again we see if we can find it using very similar code here. And if we did find it, that means the card already exists, so we can't create a new one because that card already exists. Otherwise, great. Let's use our context and access the card's database that we have set up and add that card. And then we want to commit those changes, so you just call context save changes. And then once all that is said and done, we return OK, and we just let them know, hey, your card was added. So for these, I guess I'm going to do the cliche, like I'll leave this as an exercise for the viewer. But delete is pretty simple. So essentially, and let's see if I can not flub it up. So essentially what we need to do here is we need to do something very similar where we're looking for that actual card. And so essentially, like this is one of those things where I'm going to copy paste this, but know that since we're doing this a number of times, it'd probably be good to extract that out into its own method and say, hey, here's a method to actually just find a card based on the ID that I give you. So let's see. I want to say, I don't need that part. Okay, so if we don't find anything, just return an OK. You can probably come up with another thing to return if you try to delete something that isn't there. You could also do like a bad request. So this is just informing them, and you can give it a message saying, hey, tried to delete a card that doesn't exist. Did I spell that right? Yeah. And then, so otherwise, we've found the card, so we want to actually delete that. So we go back into our context, we go into our cards, and I believe it's just remove, yeah. And then we have the card stored here and found, which might make more sense to be card. And we just want to remove that card from the database. And then again, we just commit those changes. Finally, we can just return OK and card deleted. All right, pretty simple. This is going to be a very similar thing that you would do in put. Essentially, you're going to find the card that you want to actually update, and then essentially use methods on the context to actually commit those changes back to the database itself. Okay, so let's see. So like I said, this is a very simple, just kind of straightforward API that we have built here. We have this notion of cards, so we have some models that we have set up. So a card has a number of different properties on it. Since we are using an in-memory database, one of the limitations of that is that you need to make sure that all of your properties on your models that you want to create with Entity Framework that you want to make sure that they all boil down to essentially like just native types, like string, int, boolean, float, that sort of thing. You can use more complex types like arrays and things like that, but you need to map them yourself because the in-memory database just doesn't know how to handle that. Essentially, if you try to actually do anything with the context, if you didn't set up those mappings, you'll get an error and it'll say like, I don't know what to do here. And it gives you a pretty descriptive error, so it kind of tells you exactly what the issue is. So a card just has a number of properties like name, rarity, collection number, set name, etc. And then for some of these, I created some helper enums for like card rarity. Every card in Magic has like one of the 4 rarities of common, uncommon, rare, or mythic. And so it's a very simple just enum that just kind of helps me have things stored so I don't have to like remember like how to spell uncommon, which is harder than you think when you're typing in front of a bunch of people. So, okay, and then this is just card type. This is just like a very basic set of card types that you can have with by default, when you create an API project with .NET Core, you will automatically get this dependency injection extension added, and this is essentially dependency injection at work here. So you can set up any dependencies that you have and actually inject them in this configure services. So if you have some service that you want to inject into some other controller or something like that, this is where you would set that up. This is also where we tell our service about, hey, we have this DB context that we need to use. Here's our card context that we went through earlier. This is what we're going to use here. And then this also says, hey, use an in-memory database and just refer to the database as just card DB. And so this is just a very simple thing. You could also, when you're actually working with a real database, you could actually just come in here and say, for instance, use SQL Server, I believe it is. I don't think I have that part installed. So, and then this would just be your connection string that you would have. And that could be something that you could actually have in your app settings file. I think I have one here. Yeah, like you have connection strings. And so this one's just set up to be like a local DB. You could have it, I've had it where it's connected to a DB that's being hosted on a Docker image somewhere, either locally or remotely. You can have it just pointed to pretty much anywhere that you have your database actually set up. So let's get rid of that because it's going to throw errors. Okay. And then let's see. So the other big thing here is that I also added this initialize function, and it just takes in the application services from the actual app that comes into this configure method. So this gets called essentially on startup when we're configuring our app, which is why it's called configure, and it takes in an app. And so essentially I just pass some of that stuff down to this initialize function, and I use that to get a scope of the service and essentially just say, okay, here's my provider. I want to actually get the context that I have on this service. And I'm just going to initialize the database with some cards so I have something to start off with. All right? And so this is just something that you could do with a real database. Generally, your real databases are already going to have data. This is just one method that you could use for actually seeding your database while you're testing things out. Let's see. So yeah, so this is kind of where the .NET Core stuff kind of ends, and we start to get into more of the deployment side of things. If you're familiar with .NET Framework, you'll probably notice that a lot of this is very familiar. A lot of it is very similar. Like you can do things like link. You can do things like, you can use things like Newtonsoft, JSON, like you can use converters for that, like just super easily. Essentially anything that you could do in .NET Framework, you can generally do in .NET Core. It's not like it was in version 1 where there were a lot of limitations, especially with Entity Framework in version 1. Now that we're coming into version 3 and soon it'll be going into .NET Framework 5 as a whole, it's really done a lot to catch up, and pretty much anything you can do in .NET Framework, you can do in .NET Core. And generally, unless you have some sort of specific need to target a specific version of .NET Framework, maybe it's for some legacy code or something like that, but if you're greenlighting any sort of new project, generally you probably want to use .NET Core to create that project. Let's see. So, go back to our slides. So now we're going to get into deploying this with Docker. So as I mentioned, you'll want to have Docker installed in your system, and you'll want to add and edit a Docker file to your project. So if we actually jump back over to, nope, that's not what I want to do. Jump back over here, you'll see that I've added a Docker file here. So this is just a very quick, so it bases the environment that we're building this image for off of an actual .NET Core image from Microsoft. Microsoft continually puts out images on Docker Hub, so they're really easy to find. You can go on Docker Hub and just search for .NET. It should be like the top result. We set up our work directory that we want to have. We copy all of our CS proj files into this image, essentially. We run .NET Restore, which basically helps build the project. And then we copy all our source code into there. And then we run .NET Publish and have it pointing to an actual like out directory within the image. And then we go and grab this ASP.NET Core image that's also the same version. And essentially, still in our work directory, we copy from our build environment that we've set up, like from this image, we copy the out to the actual root directory of the image. And so then we define our entry point, and we basically say we want to run .NET, and we want to run it on our DLL. So this name will be different for whatever you have. It's just this because this is the name of my project. This would normally be whatever project you have, whatever the title of your DLL is, that's what you would use here. And you can find that in the bin directory if you've actually built your project once at least locally. It's like bin debug, and then you should see net core app, and then whatever version you're using, and then your DLL. So this basically just wraps, like in a roundabout way, this is really just wrapping our actual API application that we've created into a Docker image for us to use. And with that image, if we go back to our slides, we can then just, oops, I don't know why I keep wanting to click. Okay. With that image, you can actually just build and tag it with a name. So from our directory where our project lives, you would do docker build -t, and then whatever image name you want to give it. and then period to just show that, like, hey, you're expecting to find the Docker file in this working directory. So this will actually create an image local on your machine. You can run Docker images to get a list of those images. So if I run, this is a little too, let's see, this is very sensitive. Go in here. Okay, let's see. If I run Docker images, I don't know if that'll show very well. These are just a bunch of images that I have stored on my machine. You'll see that I created a local image here, and then this is a copy of that image that I actually used for setting up a repo on Docker Hub, which we'll get to momentarily. But once you build the image, you should be able to run Docker images and see that image listed. So we have the image. We need to get it into Docker Hub. So you'll go to Docker Hub. I believe it's just dockerhub.com. Let's see. Maybe it's hub.docker. Yeah, hub.docker.com. You'll create an account with them. You should do this part of your setting up Docker stage. And essentially, you just go in and you create a repository. We see that I've already created one, but I'll just kind of walk you through some of the steps. So you click on that to create it. You give it a name, description if you want, whether you want it to be public or private. Ours is set to public. You can even link it to a GitHub or Bitbucket account so that whenever you push changes to that repo, it'll actually link up to here and get those changes and essentially push out a new image for you automatically, which is pretty nice. But if we go back to my repositories, we see the one that I've already built. So if I want to make any changes to this, I just have to say docker push Jack Kinsey /mtg-api, and then if I want to have a tag name, I can put a tag name. If you don't do that, then it assumes latest. So as you can see, I just have a latest here. If I wanted to create some specific version of this, I could do that through the use of that tag name. Let's see. So once we've created that repo, if you remember, the name of the repo was Jack Kinsey /mtg-api. That was the name of the repo that I created on Docker Hub. So this is where that name comes into play. So we first want to tag our image and with that repo name. So we do Docker tag and then the image ID. So if we look at this list of images, we have the image ID there. What's nice here is you don't have to type this whole thing in. You just need to type enough to show that it's different from the others. So I usually type like the first 4 and it knows which one I'm talking about because it's generally enough to differentiate it from the others. The ones that have the exact same are essentially copies of that image. And so you would do Docker tag and then this image ID and then the name of the Docker Hub repo created because that's the tag name that we're going to put on there. And so that's why these two have the same name because I essentially just took this one that I had and created a new tag for it that matches my Docker Hub repo. Then you just have to say Docker push and then the name of your repo, and then it's going to push that up to your repo on Docker Hub. And so that actually allows us to run that on any other platform that allows you to run Dockerized containers. I'm pretty sure all the major ones support it. I know Azure does. I know AWS does. I'm pretty sure Google Cloud Platform does. If they don't, that'd be weird. I would assume that they do. I'm just not very familiar with their stuff. But I wanted to kind of go probably the easier approach, and that's just to use DigitalOcean. It's really easy to get something set up on there. There's a lot less overhead. Like, you really just go in, create a droplet, and say that you're using Docker, and you're pretty much good to go. Like, you just go in and you pull your image, and it's super easy. Oh, and by the way, whenever you do a Docker push, you may have to do Docker login if you aren't already logged in. You should already be logged in if you've already installed it and gone through that process. But if for some reason it's giving you an error, it's probably because you're not logged in to Docker. So after creating the droplet, which we'll go through, you essentially just access the console of your droplet in DigitalOcean. And a droplet is essentially like your server that you're running through their service. And you'll go in there and you'll say Docker login, put in your credentials that you used when you set up Docker originally. And then you do Docker poll and your repo name. And then you do Docker run -p 80:80. So this is essentially setting up a pass-through on that port, on port 80, so that any call to that droplet will essentially be handled by our API. And then we also just have to pass in this hub repo name that we've been using all over the place. So once you've done that, you can actually then access your API publicly via the IP address that you have with DigitalOcean. So if we come over to DigitalOcean, where's it at? Nope. If we come over here, we can actually say that we want to create a new droplet. We're just going to go with, let's see, we want to go to Marketplace. And you'll notice here there is a Docker image already created. So you would actually just click on that, and then we would just choose a region to host it in. I don't know why, but every time I go to create one, it wants to default to Bangalore. I don't know why it does that, so I'm always just like, no, we'll go here instead. And so you essentially just go through that. You can add tags to it, just kind of all the same stuff that you can always do with DigitalOcean. You can give it a different host name, that sort of thing, and then you just create the droplet. I'm not going to do that because I don't want to eat more into my funds that I have on here. So let's see. We're just going to go to the one that I already have set up. And we will go to the console. I believe I still have that open. I think it logged me out. All right. So like I said, you would do a Docker login. You're going to put in your credentials. It's going to ask you for your username and password. And then you would do Docker poll. Notice here that is there any way I can make that bigger? It's Docker poll and then Jack Kinsey /mtg-API, because that's the name, again, that we used on Docker Hub. And then we run that run command that I showed on that slide earlier. And so when we do that, when we actually execute that, it goes through and it starts it. You'll see that, hey, we're now listening on, and this basically just means local host port 80. So we're listening on that host. So now I can actually go over into something like Postman. And let me actually grab so this is my IP address for this actual container, or for this actual droplet. And we can go into something like Postman. And then the endpoint is API cards. Run that. And we get our cards that we have stored in there. So this is really cool. So, and then you can also do a post request if you want to, since we have the post set up. And we can say, okay, I'm sending a post to this, and let's just create a copy of this one. Go into the body. We're going to use JSON. And then just call this counterspell 2 and collection number 55. So remember the ID is based on the collection number and the set code. So for instance, if I said the collection number was the same, if I didn't change at least the set code or the collection number, and I try and create this, it's going to say, hey, card already exists. And then if I go in here and say, well, actually it's 55, send that, card added. And then if I go back, oh, no, I can't do that. Will it? Nope. I copy this again. If we go back to API cards and run that, we see counterspell, but then all the way down here we see our counterspell too. So hey, cool, it works. So let's go ahead and test my untested delete command, shall we? And watch it fail spectacularly. So if I remember correctly, we send a delete request to our API endpoint cards, and we pass in the ID, right? So if we look at the set code and the collection number of the one that we just added, it's going to be LEA 55. Got a 200 OK, sweet. Although it didn't tell me, I was expecting there to be a thing that said, hey, your card was deleted. So let's see if it actually deleted it. So let's go and get our cards. Okay, it didn't delete it. So there you go. So I totally did something wrong. But anyway, that's what happens when you code something live in front of people. You are going to get it wrong. So anyway, what's up? Sorry? The ID in the... Oh, did I have... Let's see. Where was that? Yeah, it should just take the ID as like as part of the endpoint. But anyway, so something is, I'm not getting I'm not getting either of the things, and it's just returning okay. So that's what's kind of weird here. So, oh wait, I think I know what it is. The image that is living there right now is based on an old image that I set up this morning, and so I didn't actually create the new image based on this yet. So that's why live it's not working. But if I actually run this locally, just to kind of show that it should be working, if we run this locally, so we can just go in here and we can just say .NET run, and it'll take its time to actually run. So now we're running, and we're running on localhost 5000. So if we change this to localhost 5000, get the cards. Not found. Let's see. I was running into this earlier, and I can't remember what I did to actually fix it. So we may not get to see this last little demo, unfortunately. Sorry? Oh, okay. 5001. And I think that's the HTTPS endpoint. Localhost, API cards. It's returning 404. I remember getting this earlier, and I can't remember what I did to solve it. There was some weird... Oh, wait. That is the problem. I'm in the wrong directory. Let's see, .NET run. Let's try this again. This is my favorite part of programming, just finding all these little things where you just totally screw everything up. Let's see. All right, now try. All right, we got our cards. Instead of creating one, I just want to try and delete. So we're going to delete, and we're going to delete LEA 54. So this first one here. I'm going to send that. Card deleted. That's good. Get. And it's gone. Sweet. All right. So yeah, that's just a very high level, super speed, just going through and just kind of talking about .NET Core. There's so much more, pretty much every single aspect that I touched on today, like Docker, working with just purely working with APIs. All these different things could really just be their own 1 hour talk in and of themselves. So this is just kind of the speed mode. But if you want to kind of play around with the code, see if you can break it, see if you can add new features or anything like that, or just use it as a starting point to just kind of play around with .NET Core, like I said, you can find that on my GitHub at github.com/JackWKinsey/MTGAPI. And I also have the slides for the talk, just in case you want to look at. I put a lot of the commands that we're running in there just so that you can have a little reference to it. And so, yeah, thanks for having me.